Alright, so let's look at matrix operations. So, what is a matrix? Matrix normally talks about, displays information in arrays. So if you like, think about it as a table. So that'll be a matrix, that'll be a matrix. It all just depends on what we're looking at. We can describe size and dimensions of matrices by looking at rows and columns. Now, I've drawn a picture here in terms of trying to remember which way rows and columns go. Columns, I always think of Greece. Think about the buildings. The columns help the building stand, so that means they must be vertical. That's the way I think of it. Anyway, if you have a look at what I've written here, A has size 2 by 2 because you have 2 rows by 2 columns. So I should really swap these around, but anyway, you have rows by columns. That's how you describe it. B has 1 row and then 3 columns. So that's 1 by 3. Alright, each of these elements inside the matrix, each of these values inside the matrix are called elements. And then we describe them with rows and columns. So what that means is you count the columns. So let's say we look at this one. We're on the second row and then the third column. That's why that element is A, 2, 3. Alright, so adding and subtracting with matrices is fairly simple. We just simply have to add the elements. The only thing we have to check is they have to have the same dimensions. So this first one here, you can see that they have the same dimensions, so we can add or subtract them. So yes, it can be done. The second one, you can see that there's 1 row by 3 columns. This one has 3 rows by 1 column. So no, we can't subtract it. And then adding and subtracting is really simple. We just simply add each of the elements by itself. So first one adds with the first one, so that's 1 plus 2. Second one with the second one, 2 plus 7, etc. So then the next one becomes 4 minus 4, 6 plus 3, giving us 3, 9, 0, 9. Second row is the same. We add it element by element, so that's 2 plus 1, 1 plus 7, 3 minus 3. Oh, sorry, it's minusing, isn't it? So 2 minus 1, 1 minus 7, 3 plus 3, minus 2 minus 2, 6 plus 6, and then minus 5 minus 4. So then we have 1, negative 8, 6, and then negative 4, 12, negative 9. Alright, scalar multiplication, what that means is we just multiply everything inside with the same number. So C is 1, negative 6, 4, negative 2. 2C means we double everything in there, so we have 1, negative 6, 4, negative 2. So then it becomes 2, negative 12, 8, negative 4. Same with negative 4C, so negative 4 times everything inside. So then we get negative 4, 24, negative 16, and 8. Alright, matrix multiplication, when you have a 2 by 2 and that's the only case we have to worry about, then you multiply the rows by columns depending on what spot they are at. So let's just remind ourselves what their matrix elements are. So that's A11, first row, first column, first row, second column, second row, first column, second row, second column. So see this, first row, first column, that means you multiply the first row of the first one and the first column of the second one. That's why you get this. Similarly, you can do it to find this element, it'll be first row of the first one and then second column of the second one. That's why you have this one. Let's just do an example of how that works. So leave a big matrix because you can see this is quite big. So first row by first column. So we have 2 times negative 2 plus 6 times negative 4. So you just simply multiply each of them and then you add them up as a sum. Then we're up to the first row and second column. So 2 times 3 and then 6 times negative 6. Then now we're on the second row and first column. So 1 by negative 2 and then 3 times negative 4. Then first row, second column. So 1 by 3 plus 3 times negative 6. Then you simply work them out and add them up. So you have negative 4 minus 24, 6 minus 36, negative 2 minus 12, 3 minus 18, and add them up, negative 28, negative 30, negative 14, negative 15. Now from here you can actually skip this part if you like. I'm just letting you know that if you have matrices of that's not the same size, you can also multiply them. So you still do the same thing, and the way you tell what matrix you get at the end is by checking the numbers outside. So you should have 2 rows and 1 column. So let's do the first row. So first row, first column, 2 times 2 plus 1 times 1 plus 6 times 3. Then we have second row, first column. So 3 times 2 plus 4 times 1 plus 7 times 3. Oops. Then we just simply add them up. So 4, 5, 23, and then 6, 10, 31. Alright, the way you tell what matrix you have, whether or not you can multiply a matrix, is you read the description below. The columns of the first is the same as the second, so that and that. So long as they're the same, we can multiply them. Then the resultant matrix is always going to be 2 on the outside, which is 2 by 1.
Row by column, multiply them line by line. Add the products, form a matrix, now you're doing it just fine. Row by column, multiply them line by line. Add the products, form a matrix, now you're doing it just fine. Row by column, multiply them line by line. Add the products, form a matrix, now you're doing it just fine. Row by column, multiply them line by line. Add the products, form a matrix, now you're doing it just fine.